Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is application of the fundamental theorem of calculus. In our previous video, we were discussing the 5 easy rules for definite integrals. We spent a great deal of time in the previous video studying the fundamental theorem of calculus, the basics, introduction and the very basic examples. Now using the fundamental theorem of calculus, let us see how to evaluate the definite integral. I'm going to show you some harder examples, unlike the basic. Here is the first example. We need an antiderivative of the function f of x, where f of x is 4x minus x square. All antiderivatives of the function f have the form. Let me write it for you. For simplicity, let me choose c equal to 0. The fundamental theorem of calculus states that this is equal to f of 4 minus f of 0. Now what you have to do is just replace 4 in this one, f of x, the antiderivative of f of x, and replace 0 here, and then just combine them with a minus sign before this. So initially we assume that the c is equal to 0 for simplicity. So let's continue the calculation. The second part would become 0 because 0 square times 2 is 0 and 0 cube times 1 over 3 is equal to 0. So this term itself turns into 0 and this would become 32 and this would be 64 over 3. So by combination I'm just subtracting the fraction. So I get 32 over 3. Hope you're clear with this example. A special notation is often used in the process of evaluating definite integrals using the fundamental theorem of calculus. Instead of explicitly writing f of b minus f of a, I'm in this form, the notation. So this notation denotes the same thing. Hope you're familiar with this notation. So hope you're clear with the previous example too. Now let's have a talk about the constancy. Any derivative or any antiderivative f of x can be chosen when using the fundamental theorem of calculus to evaluate a definite integral. Meaning any value of c can be picked. The constant always cancels out of the expression when evaluating f of b minus f of a. So it does not matter what value is picked. This being the case, we might as well let c is equal to 0. That won't be a great problem. Hope I have mentioned the same point in a previous video too. Here is the next set of examples. I have collected different types of questions. One as a power, one is from the trigonometry, and one is exponential, one is square root, like that. So once you are familiar with all these types of examples, then you will be very confident in applying the fundamental theorem of calculus. Okay, now let's see the solution for each of this question. For the first one, negative 2 to 2. So let me rewrite that in the notation. Instead of f of b minus f of a, I'm going to write the notation form. So the antiderivative, then apply this limit, minus sign in between and apply this limit, which turns into 0. Hope you're clear with this one. Okay, now let us move on to the second one. Here is the second question, 0 to pi sin pi dx. So what is the antiderivative of sin x? Yes, negative cos x. So write the antiderivative with the same limits and plug in the limits one by one with a minus sign in between. So let's see what we are getting in this. Now substitute pi in the place of x and substitute 0 in the place of x. So this value is just 1 minus 1. So 1 plus 1, which is equal to 0. These examples may look very simple, but actually you should be familiar with all these because you can use these examples as formulas in your higher level problems, advanced level problems. So this is interesting. It says that area under one hump of a sine curve is just 2. Am I right? Okay, now let us move on to the third example where we were using exponential e. Here is the third question. So its antiderivative is also e raised to t, right? So e raised to t, I'm going to write that in the notation 0 and 5. Using the calculator you can find this value. So e raised to 5 minus anything raised to 0 is equal to 1, right? So this would be 1. So this is going to be approximately equal to, I'm going to round the answer for with 2 decimals. So this is going to be 147.41. Your scientific calculator will be very helpful in this type of problem. Hope you're clear with this one. Okay, now let us move on to the fourth one, a square root type. One thing we are all very familiar. A square root can be written as power 1 over 2. Am I right? So this can be rewritten as, now again find the antiderivative of this and write that in the notation and apply the fundamental theorem of calculus. and 2 over 3 is common for both the limits, so you can take that out and apply the limit. So I'm getting 9 raised to 3 over 2 and 4 raised to 3 over 2. You can also split the exponent, right? 1 over 2 times 3. So if you take the square root of 9, it's just 3, and square root of 4 is just 2. So that would become 27 minus 8. So finally I'm getting 38 over 3. Please check whether you're getting the same value or not. 38 over 3. Hope you're clear with this fourth example. Okay, now let us move on to the next one. A constant one. Here is the fifth one. So taking the constant out and the antiderivative is just x. So 2x, 5 and 1. I'm getting 8. This integral is interesting. The integrand is a constant function. Here we are finding the area of a rectangle with width 5 minus 1, which is equal to 4, and height is equal to 2. So 4 times 2 is 8. Notice how the evaluation of the definite integral led to 2 times 4, which is equal to 8. In general, if c is a constant, then so this is how we proceed. You can just take 2 outside 2 and 5 minus 1. 5 minus 1 is 4, so 2 times 4 is 8. That is what we are getting. In this step, you can take 2 as a common factor out. That is what they are saying. So whenever you are getting integral of the constant function type, you can proceed in this way. Hope you are clear with this set of 5 examples. Okay, now let us move on to the next topic, the understanding motion with the fundamental theorem of calculus. The derivative of a position function is called the velocity function, and the derivative of a velocity function is an acceleration function. Now consider definite integrals of velocity and acceleration functions, especially if v of t is a velocity function. So what does integration a to b v of t dt mean? The fundamental theorem of calculus states that this would be v of b minus v of a, where v of t, the capital V of t, is any antiderivative of small v of t. Since v of t is a velocity function, capital V of t must be a position function, and v of b minus v of a measures the change in position, or you can say it simply as displacement. Does this make sense to you? So this is what we are going to do using in the motion with the fundamental theorem of calculus. Now let's take an example where we can find the displacement and distance. So in that you will be using a velocity function v of t. Here is our next example on displacement and distance. Please read the question once. An equation is given for the velocity function negative 32t plus 20 feet per second, and we are supposed to find and interpret integral 0 to 1 v of t dt and integral 0 to 1 absolute value of v of t dt. So using the fundamental theorem of calculus, for this one you just replace v of t by this expression minus 32t plus 20, and the antiderivative of that would be, its antiderivative is supposed to be negative 16t square plus 20t. Now substituting 1 and 0 with a subtraction sign in between, I'm getting 4. You can work out that and check whether you're getting the value 4 or not. So thus, if a ball is thrown straight up into the air with velocity function v of t, which is equal to negative 32t plus 20, the height of the ball 1 second later will be 4 feet above the initial height. So this is what we interpret. You have to find the answer and interpret it according to the scenario given in the question. So note that the ball has traveled much farther. So it has gone up to its peak and is falling down. But the difference between the height is at t equal to 0 and t equal to 1, which is nothing but 4 feet. So if we wish to find the total distance traveled, we must evaluate the second one, absolute value of v of t. Noting that negative velocities will reduce the displacement. Am I right? So the negative sign before the velocities, that will just reduce the displacement. So keep it, please note this point. But we want distance here, not displacement. So in this case, we know that the velocity changes sign once when v of t is equal to 0. So t would be, what you have to do is just set v of t equal to 0. The left side of the equation equal to 0. And solve for t. So that would be, so t would be negative, okay, it's a 20 over 32, which is nothing but 5 over 8 seconds. Am I right? So your time t is 5 over 8 seconds. The velocity is positive over the interval 0 and 5 over 8 and negative over 5 over 8 and 1. Hope you are clear with this point. Now let's find the absolute value of the v of t. For v of t, again we are going to plug in this equation and split it. Hope you remember the 5 rules that I gave you at the very starting of this video. So according to that, we are going to split the integral. Hope you are clear with this step. Now you have to find the antiderivative, the same antiderivative which we used in the first part of this example. So that would become negative 16t square plus 20t. So applying the limits, I get 25 over 4 minus of minus 9 over 4. Since the denominators are same, it will be easy for you to do the fractional calculation. So this is just fractional addition. So just add the top row and divide it by 4. So I'm getting 9 as the final answer here. So the total distance traveled over 0 to 4 is 9 feet. That's it for this example. The positive area between v of t and t axis is 25 over 4 and negative area is negative 9 over 4. When we add these two areas, we get the displacement of 4 feet, the first part. But when we add the absolute value of both of these areas, we get the total distance 9 feet. Do you understand the difference between the first part and the second one? Okay. That's it for this video. In case if you get any query regarding this video, please let me know. See you in the next video. Have